Hey, and welcome to our last video of this course. I'm going to cover two sections here because this is mainly informational. U5A4 covers other wave behaviors of light. So when scientists study light, they've noticed things such as dispersion and polarization. So polarization has been important in glasses, like in vision, and also in TV sets. And then there's the idea of dispersion. So refraction, I want you to try and take a look at a few of the formulas and be able to get the basics of those formulas down. Dispersion and polarization are only going to be informational. There are three content sections there, 1, 2, and 4. I took out something called thin film theory, which has to do with dispersion. Now, the last section you have to do only has one content part to it, and it's just reviewing the electromagnetic spectrum. I almost think this should have been front-end loaded, but basically what they're doing is they're looking at the contributions of Maxwell and Hertz here. So just make some basic notes on what they've done for testing purposes. One thing that we probably didn't do a good job of spelling out in grade 10 is that electromagnetic spectrum, we've got the electrical part of the wave here, and perpendicular to that, excuse my drawing, in the red is the magnetic wave. So this is electromagnetism is a 3D wave. Take a look at that as you're going through the content. I would go back over the electromagnetic spectrum and I just make some notes on the basics. The electromagnetic spectrum spans everything from radio waves, which are 1 kilometer in length, to visible rays down to gamma rays, which are 10 to the minus 12 meters in length. That's about the diameter of an atomic nucleus right there. So we're going from very large waves to very small waves. Remember, visible light, the Roy G. Biv, is only a small part of this whole spectrum. Outside of that visible spectrum, to the right, we'll hit ultraviolet. Certain insects can see ultraviolet or detect it, as well as infrared, which is on the other part of the spectrum. So within Roy G. Biv, R, or red, would be lower energy light, and the violet, which is on the other end of the visible spectrum, would be higher energy. The energy is determined by frequency. So we have 10,000 hertz for radio waves. That might seem like a lot high frequency, but not when you compare it to gamma rays, which have 10 to the 20 hertz for gamma rays. And remember what frequency is. It's the number of waves that pass a given point in 1 second. So 10 to the 20 is an extremely high number. Hey folks, congratulations on making it this far. Make sure you make some good notes on U5A4, U5A5. I want to remind you that in this unit, I have put in a couple of videos that have C's in them. To do those videos, you're going to have to go and look at the content and get the formulas written down that you will need. Good luck with the final exam.